Hello everyone. Let's solve one question. The question is in an experiment to measure the charge to mass ratio of the electron by Thomson method, the value of the deflecting electric field and the oscillating potential is this much. Okay. And then the magnitude of magnetic field that leads to zero deflection of the electron beam is closest to how much? That means, do you know the J.J. Thomson method experiment? J.J. Thomson method experiment gives us the E by M ratio. Okay, but here our question is we have to find out the magnitude of B for which the deflection of the electron beam is 0. Okay, and given here electric field is 6 into 10 per 6 Newton per Coulomb and voltage is 150 volt. Let's see what is the J.J. Thomson experiment. And here this is the total experimental setup of the J.J. Thomson. Okay, see this is a glass tube, glass electron array tube you can say, and here the this is gas is at low pressure at this side, low pressure, and see here this is the head of the tube, and this is the cathode and this is anode, and this is cathode and anode are connected to the high potential, so that cathode gets highly negative charged and anode gets highly positive charge, highly negative charge and highly positive charge. And due to the highly negative charge cathode, electrons will start flow discharge from the cathode towards anode, and it will and this is here see from this that will go here, this is a hole, and in this pipe electron pass through this like this. Okay, and coming to this point, and see here the two plates that is yellow, and here the lower plate one is okay. So this is the electric field. We have to apply electric field so that the deflection will occur. Okay, here electric field. This is to set up the electric field. We have to also apply the potential difference should create there. Okay, so to create a potential difference, the upper plate is a positive potential. Suppose that is connected like this to a battery of positive potential and a negative potential to the lower plate, and then the electric field will set up. Okay, and that coming from positive plate to the negative plate, electric field direction. Okay, and when an electron going like this, that must deflect by this electric field. Okay, and the deflection direction will be towards the positive plate. Obviously it's like this, and will goes to the this screen, and that screen is fluorescent screen. It will glow when electron hit the screen. Okay, and if there will not nothing electric field or anything, the electron will go to in straight path, but due to applied electric field here, that electron deviates its actual path from its actual path by some distance y, suppose. Okay, and another thing also magnetic field applied here, and see the magnets in C type. This is the north pole and this is south pole, and you know the in bar magnet, if this is south pole, this is north pole, magnetic flux will come inside the bar is from north to south, and then like this. Okay, so magnetic flux is also like this, north to south. So electron also experience will experience a force of magnetic force. Okay, Okay, let me first tell you the electric force. Okay, when electron deflects like this, the electric force will act on upward direction, that is Fe is equal to QE, you know. Okay, and the magnetic field direction will be in which direction? You know, the if a charge Q is moving in with velocity v in this axis, and magnetic field is acting like this. So force will in which direction? By thumb rule you can say, if you put your thumb in velocity direction and magnetic field in inward direction, the force the palm face will say the direction of force, that is in upward direction, that is the magnetic field force. Okay, but here is electron, so our force direction will be in downward direction. Okay, so our force will be downward direction. That is Fe in upward direction, Fm in downward direction. So if we apply more and more magnetic field, at some time, electron will deflect in such a direction that the deviation will be zero. That means y will be zero if you increase the magnetic field. Okay, so the path will be like this, purely in straight line direction. It will only happen when the magnetic force is zero. Sorry, magnetic no, force not now. The total force will balance when the deflection will be zero. So the electric force will be equal to the magnetic force. So the deflection will be zero. See, y will be zero, so that Fe and Fm will be equal. Okay. So from this you can say that F is equal to E is equal to QVB, you know the magnetic force. Here Q is E, so E get cancelled, E is equal to VB. And this is the relation in between electric field and magnetic field when the charged particle is moving with velocity V. From this we have to calculate the required things. See, we have to write here that when deflection is zero, the electric force and magnetic force gets equal. Okay. And here the also energy conserved occur because total energy gets conserved. So by energy conservation you can say the potential energy, that is EV, is equal to kinetic energy. The kinetic energy because of the motion of the electron. So from this is velocity. Okay, Vm is the velocity and V is the potential. If you put the value of velocity, that is E by B, V is equal to half m Vm square is E square by B square. So B square is equal to m square by 2 EV. That implies magnetic field is equal to m square by 2 EV whole root. And if you put the mass of the electron is 9.1 into 10 per minus 31, and electric field is given, that is 6 into 10 per 6 divided by 2 into you know the charge of electron is 1.6 10 per minus 19, and our potential is given 150, I think, yes, 150, and the whole root will give the answer, that is 0.8 Tesla approx. Okay, so that is our answer. And here our aim is to know the conceptual things more. I know this solution is a two line, but I am providing the whole detailed things. So keep watching. Thank you.